Okay, so continuing our notes on this lesson, that left-hand side, if I gave you sine of theta cosine of theta equals negative 1/2, if you were to go back in your days of studying your, section 7.3, you'd think I never ever saw sine of theta times cosine of theta equaled something. That might be a little upsetting to you. But does this even come to approach or kind of look close to one of those double angles that we see on the front page? Well, it's awfully close to that sine double angle formula, isn't it? You'd say, oh, nuts, if only there was a 2 here, make it so. Make it so. You're looking at that saying, oh man, I'd love to have seen a 2 sine theta cosine theta. Instead, that can be reduced so much simpler. Well, look, double both sides and then you've got it. And then very quickly, kids will say, well, that's just the sine of 2 theta. Yes. And right now we are reviewing 7.3. Now, when your argument, when that inside portion of a trig function is something other than a simple singular variable, what we have been doing is saying momentarily, let's just substitute in a single variable to make it look a lot more familiar. So imagine that I'm giving you the sine of w equals negative 1. Now, if I gave that to you, I hope you'd say, well, I think I can do that. Where on the unit circle would sine equal negative 1? At 3 pi over 2. Now again, when you are dealing with this type of a problem, momentarily put in plus 2 pi k. Our final answer won't have that because we have strict boundaries to only go between 0 and 2 pi. But our period is very different than an ordinary sine wave right now. You have changed your period when you put in a number like 2 or 3 or whatever times theta. So really this is 2 theta. That's what W is filling in for. 2 theta is equal to 3 pi over 2 plus 2 pi k. And then you'd say, well, to solve for theta, I'm going to divide everything by 2, which is the same thing as multiplying by a half. And we'd get 3 pi over 4 plus pi k. Now, again, if you wanted all answers, you would stop here and say, this is it. But we only are answering between 0 and 2 pi, so let's let k equal 0. And you'd have 3 pi over 4 plus 0 pi. Well, that would be 3 pi over 4. Let's let k equal 1. If you have that, you have pi plus 3 pi over 4, or 4 fourths plus 3 fourths. That would be 7 pi over 4. And if you let k equal 2, you're too big. If you let k equal negative 1, you'll yield negative answers. So these are your 2 solutions that you're coming up with. Notice that there's no more plus pi k or 2 pi k. It's just these 2 singular answers. Okay? For number 8, last one. Sometimes kids are thinking, oh my gosh, wow, an identity where I have to arrive at the cosine of 2 theta. Yeah. Would we all agree, though, that the left side does, in fact, still appear to be more complicated? I mean, fractions, cotangents, tangents. I mean, I think everybody would quickly say, yeah, that looks bad. Tell you what, knowing that I need to end as a cosine double angle, it's probably better at this point to break everything into sines and cosines. You might say, well, what's going to tell you that? Well, look what our final answer should be. No tangents or cotangents in it, just sines and cosines, if you look at your front page possibilities. And yeah, at first glance, this appears to be counterproductive. You probably think of this and say you took a bad problem and you just made it worse. Perhaps it seems like that at first, but we're one baby step away from cleaning this up big time. The problem that makes this problem so ugly is the complex fractions. Multiply the top and the bottom, every single term in the problem, by the least common denominator of all these little denominators, which would be what? Sine, cosine. We're almost done. And at this point, when we distribute, I hope you can see pretty quickly what's about to happen. Cosine over sine times sine cosine leaves you with cosine squared. You multiply here, your cosines are gone. Sine times sine would be sine squared. Down below in that denominator, the signs cancel. You'll have cosine squared plus, here your cosines cancel, you'll have sine squared. Well, things are getting better by the moment because right now I don't have my complex fractions. Second of all, you look down below and you'd say, now wait just a minute. What is cosine squared plus sine squared? 1. And with that formula sheet that we have, you can look right here and say, well, that's one of the 3 forms of the cosine of 2 theta. This is it. And this is what we need to arrive at.